four identical resistors are connected as shown. What is the ratio of current in X to current in Y? Since we need a ratio, I can choose specific values for resistances and let each resistance be 1 ohm, so 1 ohm for each, and let potential difference of voltage across these points A, B, be 1 volt. And we know that voltage in parallel is the same, so voltage across X is 1 volt and resistance is 1 ohm, hence current for X can be calculated, it's voltage over resistance, so it's 1 over 1, so it's 1 amp. And if we consider these two resistors as one with total or equivalent resistance, which can be found using this formula for parallel, it's 1 over R total, it's 1 over R1 plus 1 over R2, but when resistances are equal, you may find the total resistance just if you divide the resistance of 1 by the number of resistors, so it's just 1 divided by 2, so the total or equivalent resistance is 0.1 ohms, and resistance of this component is 1 ohm, and total voltage across them is 1 volt. It is equal to voltage across AB, and we know that components in series divide total voltage proportionally to their resistances, and this component with resistance 1 ohm and this component with resistance 0.5 divide 1 volt in ratio 1 to 0.5, and it's the same as 2 to 1. And how to divide 1 volt in ratio 2 to 1? There are 3 parts in total, so it's 2/3 multiplied by 1, or just 2/3 volts, and 1 over 3 multiplied by 1, 1/3 volts. So voltage or potential difference across these points and across this component, it's 2/3 volts, and voltage across these points is 1/3 volts. And again, voltage in parallel is the same, so voltage across this is 1/3 and voltage across this is 1/3, hence voltage across Y is 1/3, and resistance is 1 ohm, hence current for Y can be calculated, voltage over resistance is 1/3 amps, and hence the required ratio is 1 divided by 1/3, so it's 3. So D is correct, and that's all for this question.